Welcome to The Explainer. Okay, let's jump straight into things. Today, we're unpacking what is arguably the defining planetary crisis of the 21st century, marine plastic pollution. Since large-scale production really took off back in the 1950s, our global output has just skyrocketed. We've now blown past a staggering 400 million metric tons of plastic produced every single year. But the real story isn't just about how much we're making, it's about where all this stuff ends up and what it's doing to our planet's life support system.
I want you to really absorb this projection for a second. By 2050, the oceans could contain more plastic than fish by weight. More plastic than fish. It's just a stark, honestly kind of violent scientific projection. The stakes here are absolutely massive. We are way, way past just talking about a litter problem. We're staring down the threat of an irreversible ecosystem transformation that's going to alter the actual biology of our planet.
So to really grasp this, we're going to break it down into 5 quick parts. 1. The scale of the crisis. 2. The anatomy of pollution. 3. Marine and human impacts. 4. The economics and climate connection. And finally, 5. 3 modeled scenarios for 2050.
Okay, part 1, the scale of the crisis.
Before I throw the data at you, I want you to challenge yourself. How much plastic waste do you think actually enters the global ocean system every single year? Just get a number in your head.
Well, the reality is an estimated 8 to 11 million metric tons annually. It's almost impossible to wrap your head around that kind of weight, right? So picture this. Imagine dumping a literal garbage truck completely full of plastic into the ocean every single minute of every single day. That's the baseline influx we're currently dealing with. Crazy, right?
Now, here's a fact that absolutely shatters a really common misconception. When people think of ocean plastic, they usually picture abandoned fishing nets or, ships dumping trash. But actually, land-based sources make up the vast majority. We're talking about mismanaged municipal waste, river systems that basically act as giant conveyor belts straight to the sea, industrial leakage, and of course the absolute flood of single-use packaging. And when all that waste actually reaches the ocean, it gets swept up into these massive circulating currents called subtropical gyres. You've probably heard of the Great Pacific Garbage Patch, right? But here's the crucial thing. It is not a solid island of floating trash you can just walk on. Scratch that image from your mind. It's more like a massive, diffuse plastic soup. It covers an area larger than many entire countries, but the vast majority of its mass is actually microscopic fragments just suspended beneath the surface.
Which brings us to part 2, the anatomy of pollution.
You see, plastic is engineered for extreme durability. It is not meant to biodegrade. So when it sits out there in the ocean, it just gets battered by waves, mechanical stress, UV sunlight, but it doesn't decompose like an apple core does. Instead, it relentlessly fractures. It starts out as macroplastics, that's the visible debris. Then it breaks down into microplastics, which are smaller than 5 millimeters. And finally, it shatters down into nanoplastics. And this is the ultimate terrifying endpoint of that whole fracturing process. Nanoplastics are totally invisible. We're talking plastic particles at the molecular scale. They aren't just floating in the water anymore. They have literally entered the global biogeochemical contamination cycle. Scientists are now finding these particles absolutely everywhere, from the deepest ocean sediments all the way to Arctic sea ice.
Let's look at part 3, marine and human impacts.
Over 800 marine species are documented to be affected by this crisis. On one hand, we've got the visible threats, animals tangled up in nets, drowning, or literally starving because their stomachs are just packed full of plastic debris. But the invisible threats, they're arguably worse. Microplastics disrupt reef habitats, they carry toxic chemical additives, and crucially, they get eaten by plankton. That disrupts the foundation of the entire marine food web. It's like a domino effect. And because it's in the food web, guess what? It doesn't stay in the ocean. This pollution travels straight back up to us. The exposure pathways are everywhere. We're ingesting these persistent particles through contaminated seafood, trace amounts in our drinking water, and even through airborne particles we breathe in. The science on this is moving incredibly fast right now. Recent biomedical studies have actually confirmed the presence of microplastics in human blood and lung tissue. Yeah, researchers are actively investigating this as a chronic environmental health risk. They're looking closely at how these particles might trigger endocrine disruption, internal inflammation, and cellular damage. So we aren't just polluting the planet anymore. We are literally absorbing that pollution into our own biology.
Moving on to part 4, economics and climate systems. If current rates keep up, the financial toll by 2050 is going to be staggering. We're looking at severe risks of total fisheries collapsing because of habitat damage and contaminated catches. Coastal economies are going to suffer massive tourism declines as beaches get overwhelmed with debris. And the cleanup costs alone, they're projected to reach hundreds of billions of dollars every single year. It's an absolute economic hemorrhage. But here's a surprising twist that a lot of people don't realize. Plastic pollution interacts directly with climate change. As plastics degrade out there under the sun, they actually release greenhouse gases like methane and ethylene. Plus, by disrupting plankton, which are basically nature's tiny carbon vacuums, plastic pollution indirectly destabilizes the ocean's ability to pull carbon out of the atmosphere.
This brings us to part 5, 3 scenarios for 2050.
Let's systematically compare these 3 model trajectories side by side. First up, business as usual. That's the nightmare scenario. More plastic than fish, severe biodiversity loss. Then there's partial intervention, where we see some moderate reductions in single-use plastics, but pollution still totally overwhelms developing regions. And finally, the only sustainable path, systemic transformation. By enforcing a global circular economy and large-scale bans, we could actually begin the partial recovery of our marine ecosystems.
Now, to get to that systemic transformation, we do have several emerging innovations in the works. We're seeing the deployment of large-scale ocean cleanup systems and autonomous collection devices. There's also major investment in advanced chemical recycling to break plastics down to their raw materials, along with a huge boom in plant-based bioplastics. But it's absolutely vital to acknowledge their limitations. Scalability and energy efficiency remain massive, massive hurdles. Which brings us to a really crucial scientific consensus. Honestly, no technology, no giant ocean vacuum can fully solve plastic pollution without reducing production right at the source. UN treaties, extended producer responsibility laws, individual recycling, they all help for sure. But curbing that initial production of 400 million metric tons, that is the ultimate lever we have to pull.
Conclusion. The ocean in 2050 is still being written.
The ocean of 2050 will reflect decisions made today. That's the key takeaway here. The future relies heavily on rapid, aggressive policy action and systemic transformation beginning right now. You, me, industries, governments, we all still possess agency in this global narrative. It's not a done deal yet. This science is totally clear on what happens if we do nothing. The question is no longer whether this crisis is real or if it's severe. The only question left is this: will humanity act fast enough to change its trajectory before those irreversible tipping points are reached? It is a massive challenge, but understanding the mechanisms at play is the absolute first step towards solving it. Thank you so much for joining me for this explainer.